Hi everybody, welcome to You Can Do Math. Today we are going to find the surface area of pyramids. Pyramids that have a regular base and an irregular base. All right guys, let's get started. All right guys, we have 4 problems for today, and the first problem is a pyramid that has a regular base. Now remember, regular means that all the sides are congruent and all of the angles are also congruent, and surface area is everything that we can touch on the outside, right? So we're finding the area of all of the parts of the pyramid and basically adding them together, but there is a formula that we can use for the surface area of a pyramid. And so that formula is, and I'm going to abbreviate SA for surface area, and it is 1/2 of the perimeter of the base times the slant height, which we use a cursive L for, we mathematicians, plus the area of the base. All right, so let's go ahead and plug in what we know. Well, we can calculate the perimeter of the base, and each side of the base is 6. So 6, 12, 18, 24 is the perimeter. And the slant height is, and let me show you, this is the slant height right here. The true height, if you remember, is from the top of the pyramid straight down to the base perpendicular, but this is our slant height. So our slant height is going to be 8.5 plus the area of the base. Since the base is a square, the area is just our length times our width, and it's going to be 6 times 6, which is 36. I don't know why I put that in parentheses. No clue. Okay, so what I would recommend next is multiplying these 3 together and then writing them down. So 1/2 of 24 times 8.5, that is 102, plus our 36. So that gives us a total of 138 inches squared because we are finding the area. All right, 1 down, 3 to go. Let's take a look at number 2. This second question here, what do you notice about the base? Is it regular? That would be the first question I would ask. And it is, because all of the sides of our base here is 7. So this is a triangular pyramid where this is our base, 7, 7, and 7. And this is our cool pyramid with our slant height of 5.4. All right, so I'm going to go ahead and write down surface area equals 1/2 perimeter of the base times the slant height plus the area of the base. You know me, I love just writing down that formula every single time we do a problem. So equals 1/2. Now the perimeter of the base, because it's still a regular, right? It's a regular triangle. We have 7, 7, 7. So that gives us 7 plus 7 is 14 plus 21 times the slant height of 5.4. Okay, and then we have the area of the base, and the area of the base, because it's a triangle, is 1/2 base times height. So I'm going to do a capital B over here and do 1/2 base times height of our base. And I just want to take a minute to kind of highlight that. So I'm going to highlight it on the diagram here. We want to find the area of this triangle, that's capital B. Okay, and so to do that, we want to take a look at the base of that triangle, which would be 7, times the height of 6.1. And let me show you with here, base times height. Remember the base and the height, right? They're going to intersect at 90 degrees there. So you can see that there's that perpendicular marking, our base and our height of our triangle. All right, and so now if you do 1/2 of 7 times 6.1, that is 21.35. And so that's going to go up here, 21.35. And then from there, I want you, the same thing that we did for the last problem, calculate this part, a half of 21 times 5.4, and that's going to give us 56.7 plus our 21.35, and when we add those two together, we're going to get 78.05 meters squared for our final surface area. Okay, let's take a look at example 3. So for example 3, the question becomes, is this a regular base? Well, let's take a look at the base. It is a hexagon because it has 6 sides, 1, 2, 3, 4, 5, 6, and it is regular because it does have the congruent markings for the sides, and then it also has the congruent markings for all of the angles, and then you know it's regular. All right, so that's good to know. We're going to start off with our formula of 1/2 perimeter of the base times the slant height plus the area of the base. Okay, so 1/2 the perimeter of the base. Since it's a hexagon, it has 6 sides and each side is 6, so that would be 36 times our slant height, a 12.2. Now, how do we find the area of our base? Since our base is a regular hexagon, down here it is 1/2 apothem times perimeter, and that's how we're going to find the area of that base. So 1/2 of the apothem, and the apothem is the distance from the center of that regular polygon, which is right here, to the side perpendicular, right? Not to the vertice, to the side perpendicular. And that is our apothem, and it is 5.2 times the perimeter, which we've already calculated, is 36. Okay, so 1/2 of 5.2 times 36, that's going to give us 93.6, which goes here. All right, next step. Let's go ahead and calculate 1/2 of 36 times 12.2, which is 219.6. And then we're going to add it to our 93.6. So our final surface area is 313.2 inches squared. All right, so those are our first 3 problems that have a regular base. They're going to follow that same formula, 1/2 of perimeter times the slant height plus the area of the base, and the area of the base is going to change with this assignment, just depends on what type of base that we have. So what if our base is irregular, okay? And that would be a rectangle. Not all of the sides are congruent with a rectangle, and so we're going to have a different situation for a pyramid if our base is not regular. What I would like to do is I'd like to draw out, like, what if the top of that pyramid bursted open and all of the layers laid flat, all of the sides of this pyramid laid flat. So what would that look like? So I'm going to draw a picture of what that potentially would look like. I'm not very good at drawing, so you're probably much better than me at doing this. So I'm going to do that, and that, and that, and that. Okay, obviously not drawn to scale. And so let's see, I will do different colors. Let's do, this would be the 10 feet, right? And this would be the 7 feet. And the slant height that connects to the 10 is going to be the 10.6. And then the slant height that connects to the 7 is the 11.2. Okay, so do you see, hopefully you can visualize like the top of your pyramid. If we just cut the little top of it off and it just laid flat, that's what it would look like, kinda. Sorry. Okay, so if surface area is everything that we can touch, right? The area of everything that we can touch, then couldn't we find the area of each of those 5 parts, right? The base and then the triangles, and just add them all up, and it would give us our surface area? Yeah. Could you do that with any pyramid? Yeah, you could definitely do that. In my opinion, it's the best way to do it with an irregular base. That's just my strategy. It's what I like to do. And sometimes it's very helpful to draw a picture and kind of visualize it. So I'm going to switch gears now, and I'm going to choose a blue color, and I'm going to write down the area of each part, and then we'll add them all up. So let's start with the base. It's 10 times 7, so that is 70, right? That area of that rectangle is 70. You with me? Okay, good. So now let's take a look at the 2 triangles that have a base of 10. So right here, base of 10, and then this height of 10.6. So we want to find the area of this triangle and basically times it by 2, right? Because they're both the same on either side. So let's do that. So that triangle is 1/2 base times height. So it would be 1/2 of 10 times 10.6. Okay, good. All right, so 10 times 10.6 and take 1/2 of that is actually exactly 53. But we have 2 of them. So this is 53 and this is 53. All right, so to find our total surface area, we started off with 70 plus 53 plus 53, which is 106. Okay, and then we could just do this for reference. Good. So now we just need to find the area of both of the triangles on either side now of this pyramid, and then we can just add them all up. So now we have 1/2 base times height of this guy right here and this guy right here. All right, so 1/2, that base is 7 and that height is 11.2. So 1/2 of 7 times 11.2 is actually 39.2. And if we multiply it by 2, because we got 2 of them, right? This one's 39.2. This one over here is 39.2. And 39.2 times 2 is going to give us 78.4. And so now we're just going to add up those 3 to give us a grand surface area of 254.4 feet squared. All right, guys. I know that this one is a little bit of a lot. If you have questions, please let me know. Some helpful tips. First thing I would do is I would make sure that you know what type of base you have before you get started. So when you're looking at the problems at the homework, look at the problem and then make a decision. What type of base is it? Is it regular or not? And then from there, is it a square? Is it a triangle, or is it a regular polygon where you have to use 1/2 of the apothem times the perimeter? Okay, I hope you guys enjoyed today's lesson, and make sure to like the video and subscribe to my YouTube channel if you haven't already. All right, see you guys till next time.